Hi, welcome back to Moose in Chemistry. Today's lesson is Net Ionic Equations, lesson number 2. Now we did an earlier lesson with this, so this lesson is kind of an extension of the first lesson in which we're going to be practicing some more problems. We're going to do about 3 or 4 problems in this particular lesson. So the first things we need to do, we need to check this equation. It's not balanced. So we need to put a 2 here for sure, and we need a 2 here for sure, and that would take care of everything. All right, now everything is balanced. So this is what we call the balanced equation. But let's look at these guys here. Look at these states. This is aqueous and aqueous. Something changed here. We got a solid state, so we got a precipitant, and we have an aqueous here. Now that we have a change of state in one of the compounds, we can write what we call a net ionic equation. So, and the net ionic equation is an equation which shows, what elements really changed in the equation to start with, or compounds. So let's go ahead and get rid of these arrows here. So when we write the net ionic equation, we have to first go through something called an ionic equation, which we'll call the IE. So this would be 2Na AQ plus 2Cl AQ plus PB AQ plus 2NO3 AQ. Notice I took this number here and put it in front, okay? Please look at that. It's important. All right, yields. Okay, this is PbCl2. You can't break apart solids. They're solids. So we leave that alone. This is going to give me 2Na AQ plus 2NO3 AQ. Okay. Alright, so we really should put the minus sign here and the plus sign here, plus 1, minus 1. We should put a minus 1 here and a plus 2 here. A minus 1 here and a plus 1 there. Okay, this is called the ionic equation. This is broken down into its individual ions. We can't break solids apart. All right, so let's make what we call the net ionic equation, okay? So to do that, we have to cancel out things that are the same. We call those the spectator ions. So look at this. Sodium's AQ did not change on either side of the equation. So it's a spectator ion, and we can get rid of that. Let's look at chlorine. Chlorine went from an AQ to a solid, so we don't touch that. Lead went from an AQ to a solid, so we can't touch that. But our nitrate ions stayed from AQ to AQ, so they stayed the same. So they're also spectator ions. Now the net ionic equation for this would be 2Cl minus 1, of course, AQ plus PB plus 2 AQ yields PbCl2 solid. And that's an example of a net ionic equation problem. I said we're going to do 3 or 4, so let's look at a couple more real quickly. Let's clear all the drawings here, and we'll be right back. Okay, now I've written this equation. Potassium oxalate plus calcium chloride yields potassium chloride plus calcium oxalate. All right, so now we've got all our oxidation numbers above, and we simply need to balance this equation. And to balance this equation, we're just going to have to put a 2 in front of here because that balances the K's and the Cl's, and we're all good. So this is the balanced equation. So now we need to write the ionic equation. So remember, we're not going to break apart solids, so we're going to call this 2K plus 1, and that's going to be AQ plus C2O4 minus 2, and that's going to be AQ plus Ca AQ, and of course it's a plus 2, plus 2Cl minus 1 AQ. Remember, we're going to take this 2 here and put it in front right there. This is going to yield 2K plus AQ plus 2Cl minus 1 AQ plus Ca C2O4, and that's a solid, so we can't break that one apart. It's just going to have to be together. Now, we're going to do something called the net ionic equation. So remember that spectator ions are ions that are on the reactant side and the product side. They don't change the state. If they're AQ on one side and they're AQ on the other side, then they're spectators and we get rid of them. So let's check our potassiums first. Oh, look, potassium's AQ on both sides, so we're going to get rid of that. That's a spectator. Let's look at our oxalate. Our oxalate, oh, it's changed, so we can't touch it. Our calcium is AQ on one side, and it's solid on the other. We can't touch that one. However, our chlorines are AQ on this side and also AQ on that side. So let's write the net ionic equation for this, okay? So let's see here. We're going to go the oxalate first, C2O4 minus 2 plus, of course, Ca plus 2 AQ yields Ca, of course, C2O4, plus 2 there, plus 2 there, and that's a solid. And that's our net ionic equation. Okay, let's look at one more equation. So we're going to clear these drawings, and we're going to set up another equation. Okay, let's look at this one. It looks like zircon hydroxide plus nitric acid yields zircon nitrate plus water. Oh, so we forgot the AQ down here. Okay, there you go. All right, now let's write our ionic equation for this. Oh, look, we're not going to break apart the ZrOH4 in this case because it's already solid, so we really can't touch it. So that one's okay then. So, all right. Oh, but we can break this one apart. This nitric acid could be 4H plus AQ, and that's a minus 1. This must be a plus 4 then. Okay, plus 4NO3, okay, AQ, and that's a minus sign there. Yields, okay, we can break this apart. And this, of course, is going to be a plus 4, minus 1, minus 2, plus 1, of course, minus 1, plus 1. Just go ahead and put these out just to make sure we remember that. Okay, so now, oh, look, we can break this apart. And this is going to break into Zr plus 4. And that's a AQ plus 4NO3 minus 1. That's also AQ. Oh, look, we can't break apart solids or liquids. So we're going to write this as 4H2O. Okay, so, that looks interesting. So this is going to be kind of really cool to see what really happens here. So let's look at our net ionic equation for this particular one. Okay, can we touch the H's? And the H's, no, because they're aqueous here and they're liquid here. So we can't touch it. Our nitrates we can touch because they're aqueous on both sides. So that's a spectator and that's a spectator. And our ZRs go from solid to aqueous, so we can't touch that. So the net ionic equation is going to look something like this. Zr plus 4, OH minus 1 for solid plus 4 H plus AQ yields ZR, ZR plus 4 AQ plus 4 H2O. That's pretty cool. Amazing. Okay, well, that's it for this lesson in net ionic equations. I'm sure we'll have several more to come in the future. And we hope you enjoy your day. Have an awesome day, and we hope to see you back at Moose in Chemistry.